Hey, hi Sushant. I'm good. How are you?
I'm also doing good, thank you. Yeah, Nikhil, so can you please give a brief description about yourself and your work experience and a little bit more about any of your projects that you have done?
Sure, Sushant. First of all, thanks a lot for giving me these opportunities.
Mhm.
My name is Nikhil Kumar. I have completed my graduation in 2021 and right now I'm working as a data scientist. I'm carrying around 5 years of experience in the field of machine learning and data science, where I have worked on multiple different types of projects. It's either it can be a simple machine learning based project, deep learning based projects, few of the time series based project. Also, I have a good hands-on on the Tableau, and right now, in the last 3 year or more than 3 year, I am working with the generative AI-based projects. Either it's a generative AI, agentic AI, or the MCP one. So these days MCP is much more in the booming field. So right now, I'm working on that field. So if I talk about the experience in the cloud section, I have worked mostly on the Azure side. On top of that, I have also worked with other cloud services like GCP or AWS. This is the whole journey for what I have worked on. Let me know if you want to go through any of the project in much more into detail. I'll take you through that.
Okay, yeah, that's the work experience sounds good. So in the end, you mentioned that you also worked on an MCP, right? So can you just briefly describe what MCP is, what you worked on? Yep.
Sure. So assume that I'm working in an organization, and right now that the website of that organization is being hit by many of the persons. So let's take example of a simple example of ServiceNow. Now, ServiceNow is a very big organization in which people used to generate the ticket. Few of the people are there who are used to resolve those tickets. Few of the people comes and comment it out. So those multiple things are there. Now, assume that I just want to improve my services or I just want to change anything. For that, I need to do any alteration in my particular code or anything. So lots of things can be changed. Either a response will be changed, API will be changed, and all those things will be changed. So in that case, other developers who are working and they are trying to generate few of the tools using the agentic tools so that all those things can happen on its own. So in that case, they also need to make those changes. What our system is doing those changes because our response would have changed or either input would have changed. So all these things they also need to take care of that. So in that case, lots of hustle was being there. So assume that to resolve those issues, what I'll do is that for all those, you can say that the services or all those functionality, I will create a tool for each of the functionality, and I will leave that tools on a server on our server. No, now so assume that if someone want to use any other tool, so they don't need to come to our inside our system. They just need to hit that MCP server
Okay.
so that they will directly hit the MCP server, use the particular tool. Now, whatever input is there, input will be always be the same. If we are making any change in our backend, they don't need to make their change on there because we already our developer makes changes on the tool, and that tool will take the same input and the output will remain also the same. So in this case, whatever changes we are doing at our end, so it will remain at our side. Other team will not get disturbed, and it's the organized way so that anyone can go and hit it if they don't have any of the prior knowledge of development or any such thing. So any normal person can also use those tools. So this is called the MCP. The full form of MCP is Model Context Protocol. So basically, the agenda of this is to basically, as we know that these days LLMs are booming in this field. So to provide a much more context to the LLM so that LLM can understand better and can do a better functionality, we are using this MCP servers.
Okay. Sounds good. So
Hope I may have able to clarify it, but let me know if you want to go deeper into that. I'll take you through that.
okay, no, that sounds good. So what you are saying is basically the clients who are using the server, they don't have to manually change their code. So whatever is in the server will be automatically handled by the company developers. Is that right?
Makes sense. Exactly.
Okay, yeah, that sounds good. Okay. So yeah, let's continue to the interview. So the format of the interview will be first we'll start with some basic Python questions. Let's say two Python questions, and then we can delve deeper into support vector machines and machine learning, and we can discuss some questions regarding that. Does that sound good?
Makes sense, Sushant. Yeah.
Okay, yeah. So if you can just open any Python interpreter in your local machine.
Sure. Would you like me to share my screen?
Yes, please.
Yeah, give me a second. Let me know if my screen is visible to you.
Mm-hmm. Yeah.
Let's go.
Yeah, this should be fine. Yeah. Yeah, so the first question is, let's assume that you have a list of numbers, list or an array, whatever you, so list of numbers, and you, what you need to do is define a function, which basically, if you have the list and the target number, you need to find if the sum of two numbers in that list adds up to that target number, right? So you need to return either true or false. No, sorry, not true or false, but the indexes of those two numbers, basically. Does that make sense?
We need to return the index of those two number
Mm-hmm.
whose sum will be the target. Am I correct?
Yes, that's right. So the input will be the list and the target number.
Is this correct? This is what I'm
Mm-hmm.
understanding.
Yeah, that's right.
Is this makes sense, Sushant? So basically, here target is 12,
Mm-hmm.
and zero one position is 4,
Mm-hmm.
and second position is 8. 0, 1, 2.
Mm-hmm.
So basically, 4 plus 8 is 12.
Mm-hmm. Okay. Sounds good. And what if you remove 8 from the list? What happens then?
It will return none in that case because there is no
Okay.
we are not able to reach to 12 in any cases.
Mm-hmm.
So in that case, it will return none because we did not find any of the combination.
Okay. Sounds good. Okay. Yeah, you can erase all of this. Let's move on to the second question. Okay. So Nikhil, do you know what a palindrome is?
So basically, palindromes are those strings. If we write in a reverse order and the same order,
Mm-hmm.
the string will remain the same. Example, madam, M-A-D-A-M.
Mm-hmm.
So assume that if you are starting from the left hand side or the right hand side,
Mm-hmm.
even though if you reverse the same thing, the word will remain the same.
Okay,
Am I
sounds good.
correct?
Yes, that's right. Yeah. So what you need to do is basically write a function to find if a string given string is a palindrome or not. Given that the string is alphanumerical and it is case insensitive, so it doesn't matter. Yeah.
Could you repeat once again and could you go a little
Yes.
slower, please?
Yeah. Yeah. So you just define a function where you find if a given string is a palindrome or not. Given that the string is in alphanumerical, so alphabets and numbers or anything like that, and it doesn't matter what case it is, so it can be case insensitive. Does that make sense?
Just a second. Alphanumeric, and what you repeat the last sentence?
And
What?
case insensitive, so uppercase lowercase it doesn't matter.
Is this make sense?
Mm-hmm. Okay, this looks good. All right, Nikhil. Yeah, you can close this editor. We can move on to the ML part of the interview,
Sure, sure.
and you can stop sharing your screen as well. Yeah.
Yeah.
Okay. Yeah. So Nikhil, I'm sure you might have heard about SVM support vector machines in the
Yes.
machine learning field. Yeah. So can you explain like what is an SVM?
So basically, we talk about SVM is support vector machine, which is one of the supervised machine learning based model. If I talk about the supervised machine learning based model, where we have the input and defined output. So basically, SVM is generally used for the classification based model, but we can also use for any of the regression based model too. So the main agenda is to in SVM is to find out the optimal hyperplane that will basically separate out the given things into different classes. So basically, assume that you have a two class. Now it will try to generate a particular line which will differentiate into two particular class, and from there you can understand that okay, the above thing is a particular class and lower thing is a different class. So in this, what the major agenda is to create a one hyperplane and create another two optimal hyperplane, or you can say that a marginal plane, and you try to increase the distance of this marginal plane. As much the higher the distance it will be, our model will be much more better in that cases. So the main agenda is to optimize the highest distance or the optimal hyperplane or the marginal plane, you can say.
Okay. Okay. Sounds good. So you mentioned that the main objective is to make the distance between the marginal planes as much as possible. So when you talk about margin, like what is the difference between a soft margin and a hard margin in SVM?
So basically assume that the data is perfectly linear separable. So in that case you don't want that no misclassification, you want that in that case. So it's called a hard margin. Basically, you don't want any misclassification to be happen. You don't want any uh, false positives to come. So in that case, you give even a hard margin that you want 100% accuracy. But in the same time, you want okay. I'm okay with the little bit of accuracy. If you know that your data could be a little bit error could be there. In that case, you go with the soft margin. In case of soft margin, if few of the support vectors or the point can lie either within the left hand side of the basically inside the marginal plane or outside those two. This means that if we are giving the soft margin, few of the data point can also lie in the marginal plane. You can say that or the line after the marginal plane.
Okay.
So that's called the soft margin. And if you don't want anything, that's called the hard margin. Hard margin.
Okay. Okay. Sounds good. So in the SVM algorithm, do we have any parameters that we pass in the algorithm?
Yeah, we have multiple parameters. So first parameter is that the C parameters. So as we discussed right now, the soft margin or the hard margin. So
Mm-hmm.
basically, we tune that parameter. Basically, to tune that soft margin or hard margin, we use that particular the C parameter.
Okay.
If we going with the higher C, the in that case the model will try to classify all training example exactly, and it will try to overfit the case. But if we're going with the soft margin, the model will not overfit it. It will do some of the mistake. But in that case, the model will be the best fit, and it will not the overfitted model, because assume that the scenario when you try to reach out the every possible scenario, in that case the model will try to focus on the given data point and it will try to match that. But if you are giving a soft margin, you are allowing a model that okay, you are allowed to make a mistake, then in that case you are giving a soft margin, and with this C parameter only you can do those things. On top of that, there are different another optimal hyperplane was there, that hyperparameter was there, the kernel techniques. So assume that you have a different kernels. So to find out that, assume this is the case when you have a 2D data in two plane, but assume that you have a data in 3D 4D. So how you will do that? So for that we have a different kernel, radial bias kernel, polynomial kernel. So you use those different kernels to classify our data point.
Okay. Sounds good. Sounds good. So what are the advantages of using SVM as compared to other traditional ML models?
So if I allow so basically the major advantage which I can think of right now is that the kernel technique. So even though assume that the data point in 2D plane, you can see that, but assume that if data point is a circular forms means that your data point inside the circle is of different class, but outside the circle is of different class. So what the SVM will do or the kernel trick will do, So basically, it will try to represent the data into a 2D plane. So it will try to lower down the data from higher plane to a lower plane,
Okay.
and from there you can clearly differentiate into a multiple easier classification technique. So basically, assume that you just think of a scenario that if you represent the data inside the plane, outside plane into a lower dimension, then it effectively able to differentiate that.
Okay. Okay. Sounds good. So we talked about the advantages of SVM. So do you know if there are any disadvantages of using SVM?
Yeah, there are multiple disadvantages too. So I can talk about few of them. So if you see about the high computational cost, so basically SVM can be slow to train on a large data set. So that can be one of the disadvantages I can think of right now, as the algorithm scale poorly with the number of samples. The another I can think of is that basically it's not too good when we have a lot of noisy data. So as we have discussed earlier, that with the help of a C parameter we can tune the how hard margin or soft margin would be there. But assume that a scenario where we have a lot of misclassification are there. So in that case, it will not work very good. The another thing is that the kernel selection is critical. So basically, right now we discussed that the converting the higher plane to lower plane, but you don't exactly able to know that which kernel you want to use because multiple kernels are there to find out. So it's not that all the time the same kernel would work, and all the time we find the easy kernel that would work according to our expectation. So that could be another thing. Poor performance when it's have the large feature set. So assume that if we have a multiple features, so in that case the SVM does not perform very well in those cases. Less interpretable is also there. We can't so think of a scenario where we have a decision tree or something like that. We can interpret it as that okay, the feature is not performing in this way. So we you can simply draw the complete path and you can make it understandable to some other person. But in this case, you will not be able to do that. So these are a few of the disadvantages which I'm seeing right now.
Okay. Okay. Sounds good. Does SVM support like multi-class classification or not?
So SVM inherently does not support any multi-class classification, and it's basically use the binary class only. But we can use different techniques, just like the one versus rest. So basically, you can do that. You if you have five classes, so assume that you need to classify one, two, three, four, five. So first, you can classify that okay, these are the one, and rest two to five into a different class. Now you get to know that these are the one values. Now you can separate out two and you can keep one, three, four, five into different class. So in this way you can apply the SVM and you can do for the multi-class classification also.
Okay. Okay. Sounds good. So when we talk about support vector machines, so we have the support vectors in the name. So what are these support vectors and why are they important?
So basically, we talked about the C parameters. We talk about that there is a few misclassifications are there. So basically, those points which are either lying on that the hyperplane or the point which are very closest to that hyperplane, those points are called the support vectors basically.
Okay.
So those define the orientation of the hyperplane. So basically, they are the most critical point because those only the points which are going to make your model robust, how it is going to perform. So those are the most important point in your data set. Those are called the support vectors, which are very near to the optimal plane or hyperplane. You can say that.
Okay. Sounds good. Sounds good. So does SVM also work in non-linear cases or does it only work in linear cases?
So if the data is a non-linear separable, standard SVM will not perform very well.
Okay.
To handle the this scenario, what we can use that the kernel trick. So in that case, we apply different kernel tricks as we discussed earlier. So there could be a multiple kernel tricks as we discussed right now, the polynomial one as RVF kernel. So these allow you to work well also in case of a non-linear data set. So it will. This is the major advantage over there that you don't take to be always the data set to be a linear only. Even though it's non-linear, even though if a little bit less noisy, you can perform that. But you can perform in a non-linear data set too with the help of the kernel tricks.
Okay. Sounds good. Sounds good. So how does SVM handle like imbalanced data sets?
So SVM does not have something in their own or inherent that it handle the imbalance does it. It's not like that there is a particular parameters. which I can recall right now, those are inherently in the SVM algorithm. But with the help of other DS techniques, like just like a class imbalance or giving the higher importance to a particular weight or resampling using the smooth, you can use these techniques to balance the dataset and to use it. So assume that there are two different classes. One class has a lesser point. You can give a higher weight to that class and lesser weight to the class which have a higher data point. So that's the one way. Another way is that you can use oversampling technique or the undersampling technique to increase the data point of a particular class which has a lower class, or reducing the data point of a particular class. You can use these techniques, and through that you can handle the imbalance data set too.
Okay. Okay, sounds good. So a few questions before we talked about the kernel trick, right? So there are, as you mentioned, different types of kernels: the linear, the RBF, the polynomial. So do you know what the differences are between these kernels?
So basically, there are different kernels define how the data is transformed for classification. So assume that the linear kernel is used when the data is linearly separable, as we discussed. If the data is a 2D plane, we can separate it with a simple line. So that's called a linear kernels. So it is fast and very fast because we just need to draw a simple line, and it's simple too. Now, another kernel is at the polynomial kernel, which maps the data into a higher dimension space using the polynomial function. So basically, assume that the quadratic or the cubic function. So it will try to draw the graph of those cubic or the polynomial, and with the help of that, it will draw that classify the. The third is that you can say that the radial basic function, the RBF kernel, which is used for nonlinear dataset and map points into an infinite dimension. It is very effective for capturing local pattern and is widely used for flexibility. So these are the kernel tricks which I can recall right now.
Okay, sounds good. Yeah, so the last question would be, do you know if there are any real world applications where SVM is commonly used?
So there are multiple examples where SVM can only commonly use, just like give an example of cancer classification. So basically we can use there because you can easily find out the planes and bifurcating the multiple class. Earlier it was used in the ham and spam classifiers, where basically the by bifurcating the mails which are spam mails or the good mails which you want to be read daily basis. Even though with the help of a kernel you can use for the face detection of images. So assume that if you want to detect which the faces of person, you can use that. So these are the few of the real world scenarios which I can think of. We can use SVM, and it works well in those cases.
Okay, sounds good. Yeah, I think that's it, Nikhil. Thank you so much for giving this interview. And yeah, that's it. Okay,
Thanks a lot, Susan. Thanks a lot for your time. Have a great day.
you too.